Hello, I'm recording myself explaining the class activity. So the question was how we get from this differential equation to this one down here. So we talked about two new equations. One of them is for angular frequency or omega n, and another one is for damping ratio or zeta. We're going to use these two to get to that point. Now I have this error, very annoying. So I'm going to kind of cover this part. Okay, just think about the angular frequency on its own. So what I have done is I have squared both sides of that equation, as you can see, and then from there I can say that k over m is equal to a square of omega n, and that will give me a very nice clue to replace m over k in that equation. I'm color coordinating it so everyone can understand that. So the blue side here, the blue side of the differential equation is divided by k, and then we have m over k here, and then I'm replacing it with 1 over omega n square. I hope this part is understandable. This part I already explained in the class. Now, the same way that we simplified that angular frequency, and then we have the relationship between the m and k and omega. So another way of writing the left side of this equation is by having the whole fraction in a square. So that way I can write it that if I do the square root of both sides, left side and right side, then I will have a square of m over k. A square root of m over k is equal to 1 over omega n. I'm going to use this in a second. Now, forget about this side. We are going to look at the damping ratio. So I can rewrite damping ratio, and I can do a quick butterfly method. And that way I can write it. I can write it this way. So my zeta into square root of mk is equal to c. And now if I divide both sides of this equation by k, then I will have c over k is equal to zeta to square root of mk over k. And now if I take the 2 zeta out, then I will rewrite that as mk over k square. So you know that square and square root will cancel each other, and that will come out as the k. So I will write that in this way, so I can replace the square of m over k with what I got here. So here, another way of writing that was writing it square root of m over k is equal to 1 divided by omega n. Now I'm using this one and then the result of my damping ratio to replace in my equations, and then I'm going to get this. Pay attention to the colors. I made them this way on purpose so you can understand what is happening. So the left side of the equation, f is divided by k, and then I have f over k, and then kx is divided by k, and then they cancel each other and I end up with x. The third part, the c dx over dt is divided by k. I'm following the green color at the moment, and then I will keep the dx over dt, and then I have the c over k, which can be replaced by using this formula here and this formula here, and then I will have 2 zeta over omega n. Pay attention that I'm keeping the derivatives because they are useful for my differential equation. Now I'm going to follow the blue line here. So I have m second derivative and when I divide that by k, the derivative stays as it is, and then I will have m over k here. And I explained that m over k can be replaced by 1 over square of omega n from this formula here. I put the slide on write space, and if you couldn't understand or you need me to explain it one more time, just let me know.